In this lesson, we'll be styling our circles. So although our force diagram works and each circle is positioned properly and the force diagram is responsive, this still is pretty imperfect. Every circle looks identical and we have no idea why they are positioned the way that they're positioned. First, we're going to make each circle look distinct from one another. Now we can target two properties to do this. The first is each circle's fill, or its color. Basically, we're going to fill each circle according to its continent, so that we have some clear grouping, as well as on the y-axis, also in each circle's fill. And the second will be each circle's size. We'll go ahead and add a radius to each circle that is dynamic and updates depending on that country's happiness score. So first, let's do the easier of the two, which is add a color to each circle. And in order to do this, yes, according to its continent, we're going to need a brand new D3 scale that's called scaleOrdinal. And observable, as it usually does, will have really good documentation for this, and I would encourage you to read through this, but what you're going to notice over and over again is this use of color. In specific, we could pass in a domain and range. It could be quantitative in nature, or it could be categorical or ordinal, and it will return an equivalent position within the range. So this is essentially the exact same as what you've already seen in D3 scales, in that it takes in a domain, which is an input, and a range, which is an output. And in our case, it's pretty easy to imagine what our input and output are going to be. But first, let's go ahead and import it. And again, this is from the exact same D3 scale module. And then we're going to create a new scale, and we will call it color scale. Now this is going to be scaleOrdinal, again, because that's what we just imported. And just to remind you, it uses the exact same domain, which is an input, and range, which is an output. So what is the input? Well, you might notice that I place this directly below the continents group that we've already created on line 57. Let's review what this is by console.logging it. And what you'll notice is that continents, I need to comment out this because it'll be broken for now. Continents is an array of 6 items, and you'll notice that these are actually arranged according to their mean happiness score in ascending order, where Oceania is the happiest continent according to the data, although there's only 2 countries, but still its mean is highest of those in the data. So we have 6 items in our continents array, and already we can imagine this is what will be put within our domain, right? We want to fill things according to their continent, so that will be the domain. Then the question is, what's the range? In the range, we basically need 6 colors. You could invent these colors on your own, or if you'd like, you can copy the exact same colors that I use, which I'll go ahead and paste right here. Now I'm going to save this, and nothing's going to change yet because I'm not using the color scale, but then using this is quite simple. Down here in our circle element that we're rendering on line 92, right now we're passing this constant fill of steel blue. Let's instead pass the color scale of node.continent. Remember that node.continent exists within our data, right? We have continent as a property, and then we're passing this so it'll look for the equivalent input, and based on its position within color scale, will return its equivalent color in range, okay? So if, just to belabor this point maybe too much, if Africa is the first point in our continents array, if we pass Africa into color scale, it will return the first item in our color range. In this case, DDAODD. And the same will go for the second item. Asia will be equivalent to this, South America will be equivalent to this, North America, Europe, Oceania. So that's how we'll use color scale. Let's go ahead and save. And we already see these beautiful colors begin to populate and replace our ugly steel blue. You might notice that you can't really see these top elements, so I would recommend you put a stroke on your circles, which is as simple as stroke and whatever color you want. I'm going to do a stroke of black. Optionally, you can make them thicker if you want. You can make it a very thick width, although I would recommend just using 1, which is also the default, so you can omit it. And now we have each of these circles looking pretty nice. We actually start to see the beginnings of a real styled chart because all of our circles are not the same color. So that's the first thing that we're going to tackle, is styling our circle's color. To be consistent, you might want to import the scaleOrdinal on the same line that you import the other scales, so you can move it up to line 49. That's optional, but if you'd like to do that to keep your imports consistent, you can definitely do so. Now we have our circles properly filled, and now we can move on to the second objective of this lesson, which is sizing our circles according to their happiness score. Now this is going to use yet another D3 scale, this one called D3 scale square root. D3 in-depth article kind of explains the intuition behind why we use it. And the reason is we want to set the area rather than the radius proportional to data. And this is just how, humans and brains perceive the size of elements. Circles increase according to their area, so we need to account for that in how we create scales. It's pretty fun to read about this, so I would encourage you to do so. Just know that if you're working with circles, you should probably be using scale square root. With that being said, the internals of scale square root are essentially the same as every other D3 scale you've seen. They take in a domain and a range, where domain is the input and range is the output. So it's very easy to see how we could use this in our example. We'll go ahead and create a new D3 scale, and we'll call it radius scale. And this will be a scale square root with a domain. Again, I'm writing this over and over again so it really gets in your head. Range is output. Now, what is the domain and what is the range, right? Those are the questions. Well, we already know the domain of potential happiness scores, and we have it right up here on line 51. Remember, as I said earlier, that we're kind of double encoding this happiness score. We already know from our brains that it goes from 0 to 10, and that realistically nothing goes below 1 or above 9, which is why we made this the X scale domain. So we actually want it to be the exact same domain for our radius scale. So we'll go ahead and paste that here. Now, what do we want the range to be? Well, the answer is whatever you want the size of your circles to be. So let's actually just put some testing numbers in and see what we like, and then come to a final conclusion later. We'll start off with 1 and 15. And then radius scale now can be used in our application. Down here, we have our equals radius, where radius is this hard-coded variable that you might recall is 5. We don't want to use the hard-coded radius variable anymore. We want to use radius scale of node.happiness. Let's save this and see what happens. We see that our circles definitely increase in size, but they don't look very good. There's something broken. And what's broken is that these circles are overlapping. The reason for this is we're referencing radius, that all caps variable, in one other place, and that's in our force simulation. Up here in this reactive block, you might remember that we have a force collide, which basically tells the force diagram how to account for each element's size so that they don't overlap with one another, right? It prevents collision. We're using radius here, which is obviously an issue. So rather than passing radius directly, we need to use our radius scale. Now, right now, the force collide is then passing in radius as a standalone variable, but we need to use another accessor, just like this, where we take in d and we return d.happiness, just like this, where we take in d and we return d.continent. We need to take in d and return radius scale of happiness. Now you might see that it's suggesting you add 1, and the reason for this is that there's a little bit more space between elements, so you definitely can do that if you'd like. You don't need to, it's up to personal preference. But now we can see that our circles are actually being positioned properly, they're actually respecting each other's radii, so they're not all overlapping in some huge jumbled mess. Now the issue is obviously that they're just too big, so this is why I said we should just go ahead and try some test numbers and then adjust later. I think 1 might be too small over here, maybe, so I'm gonna make that 3. And then I think 15 is simply too large. Let's change it to 8. And then let's refresh, And now you see that these elements actually look pretty good. There's a very marginal difference between the 3 and the 8, but it's enough to be noticeable. And I think that that's pretty good. I like these sizes. So I'm going to leave 3 and 8, which I think is pretty good. But what you might also want to do is change these on really small screens. So say you were even tinier than this screen. You were on a very small mobile device, and these bubbles are looking a little bit crowded. We could make this element reactive to the size of the entire application to make even smaller bubbles on small screens. How do we do that? Well, we're going to want to pay attention to the width variable and update scale square root if it passes a certain threshold. How do we do that? Yes, a reactive label. You're going to do $, radius scale. And then where do we want to reflect the width within our application or within our scale? It's going to be in the range, right? If width is above a certain number or below a certain number, we want to return a different range, smaller numbers, than if it is above or below that threshold. So let's go ahead and say if width is less than 568, random breakpoint, but people love to use 68 as kind of their suffix for like breakpoints in web design. You might see 968 a lot. I don't know, it's up to you. But you could do 568, you could do 600, whatever you want. And then if it's smaller than 568, we want these circles to be even tinier. Let's say we want it to be 2 to 6. And if not, if it's above 568, we want it to be 3 to 8. Let's go ahead and save this, refresh. Now you can see those bubbles are a bit smaller. And if I resize, you see they get bigger. So notice right as I pass this 568 point, you see the bubbles get bigger or smaller. So you could make this any number of things. You could check for an even smaller breakpoint, like 368, make them super tiny. But here, you know, what you would be using is this ternary operator, which we've reviewed before. The question mark and the colon basically says, if this is true, return this. If it's false, return this. So here we're dynamically creating a new radius scale if and when we need to, based on the width of our screen. So what have we done in this lesson? We've gone from an unstyled yet functional D3 force diagram to a pretty nice looking force diagram that has circles that are styled according to their content.
If you want to keep learning about how to build real-world apps with the latest technologies and other career-related topics, then start right now by subscribing to our channel and liking this video.